Good afternoon, my name is Mackenzie Hudgens. I go to the University of Tennessee, and this is my neuroscience project. I just want to share my research on the circadian clock. Before we start talking about the circadian clock, there's a couple of terms that you need to be familiar with when discussing this topic. The first is biological rhythm. This is a regular fluctuation in any living process. However, circadian rhythm is a pattern of behavioral, biochemical, and physiological fluctuation that has a 24-hour period. There are two rhythmic biological events. Ultradian, and this is a period that lasts shorter than a day. It lasts for either several minutes or several hours. The second one is infradian, and this refers to an event with a period longer than a day. So what controls the circadian clock that controls a lot of our bodily processes? The suprachiasmatic nucleus, the SCN. This is located in our hypothalamus in a small region of it. This is named for its location around the optic chiasm. So, what is the SCN? The SCN is our biological clock. This specific part of the brain controls major processes that happen and are important to bodily function. In mammals, light stimulus goes from the eyes straight to the SCN to signal day length. So I started thinking that if it was so important to our body and controlled so many processes, what would happen if it was damaged? This can be damaged in several ways, including lesions, trauma, stroke, and tumors. When it's damaged, it has implications to our biological processes. It can affect our circadian clock, such as hormone secretion, locomotor behavior, even eating habits. Another thing I was thinking of is if the SCN is important and it does depend highly on light stimulus to signal the day length, what would happen if you could not receive light cues? For example, people that are blind do not receive light cues. For ones that are blind, the retinal ganglion cells containing melanopsin appear to be abnormal or absent. When they are absent or abnormal, this can cause difficulties going to sleep at night and consistently being awake during the day. An implication of not receiving light is problems with melatonin. Melatonin is important because it's secreted during the nighttime to tell our body that it's ready to go to sleep. However, this is according to the light stimulus that we receive. When we do not get that light stimulus, melatonin does not secrete. So I was wondering how exactly the light stimulus goes from our eyes to the SCN. That happens through the retinohypothalamic pathway. So how does this pathway work? It's a short pathway that carries information about light to the hypothalamus to entrain our rhythms. This is the route by which retinal ganglion cells send their axons to the suprachiasmatic nucleus. It goes from the light stimulus to the eyes. From the eyes it goes to the brain, which is how it gets to our SCN, which is our circadian clock. What does the circadian clock control exactly? It can control our biological processes. Anything from the sleep-wake cycles, hormone secretion, body temperature, eating habits, and even our digestion. An important aspect of our biological processes is hormone secretion. Two very important ones are melatonin and melanopsin. Melatonin is an amine hormone. This amine hormone is secreted at night by the pineal gland. This signals day length to the brain. The second one is melanopsin. Melanopsin is a special photopigment within the retinal ganglion cells. This is what makes the retinal ganglion cells sensitive to light. I started thinking that if there was some damage to the SCN, what could happen, but I also started to realize that if this was so important to our biological processes, there could be things that could implicate these. So the activities or habits that can affect your circadian clock, some include alcohol, jet lag from travel, medications, and even shift work. I started thinking maybe I should do some research on how exactly an activity could affect your SCN, specifically alcohol. So this was created, it's a circadian clock in a 24-hour period. This circadian clock is specifically created to someone who drinks in the evening. So alcohol affects your circadian clock, your rhythms, your SCN, by, it can have reduced melatonin, and this is also all delayed So your reduced melatonin secretion starts about 11 p.m. In an average adult, their melatonin secretion starts about 9 p.m. So you go throughout your night and you get your deepest sleep at 2 a.m. And when you're sleeping, you spend more time in slow wave sleep instead of REM sleep. You go throughout, it gets to 6 in the morning, and you have elevated levels of endonisine. You also have 8:30, you have reduced melatonin secretion stops. This tends to also be delayed. You have delayed highest alertness at about 12 at noon, which should be earlier. You get your strongest sleep drive around 4 p.m. You have less physical activity. Your highest blood pressure tends to be later in the night. Relating this to someone who might have chronic alcoholism. Alcohol can delay your circadian rhythms. They affect your body in many ways, and it especially destroys the synchronization of your rhythms. It will disrupt your sleep-wake cycles by implicating the response to light cues. It reduces your melatonin, and these problems will persist every day, even though the synchronization, affecting the synchronization of your circadian clock. Instead of the entrained rhythms going back to normal, your rhythms will be consistently abnormal. After researching your alcohol effects on your circadian clock, I decided to do something that you can't really control. I decided to do something that is biological. So this is how depression can affect your circadian clock. My research that I did on depression and affecting your circadian clock, the research that I found and studied was mainly towards the nighttime and in the early morning hours. So with depression, you also have delayed responses and you have delayed secretion of melatonin. So around 9 p.m., there's decreased melatonin secretion starts. People who have depression often suffer from insomnia. At 2 a.m., you have increased body temperature. Your increased body temperature affects your restoration sleep. 3 a.m., you have low or undetectable melatonin. It goes throughout the morning. You hit your highest body temperature at 6, increased cortisol release. Your melatonin secretion stops around 8 a.m. It's a little delayed with depression. You have decreased alertness due to insomnia. And you have increased cortisol release around 5 p.m. These are abnormal secretions that happen at different times of the day, whether they're increased or reduced. So, conclusions from our research on chronic depression. Chronic depression can lead to other disorders due to the abnormality of the circadian clock, such as insomnia. It disrupts your sleep-wake cycle, and for a prolonged amount of time, it can entrain this new rhythm abnormally. Hormone secretion of melatonin is reduced, and cortisol secretions are increased. This tends to happen at delayed times throughout the day. So, in conclusion of the circadian clock research, the circadian clock of our body is very important for many bodily functions. It has a major role of how our bodies work and are able to function properly during the day and sleep at night. Our bodies are trained and technically on a time schedule, from our highest blood pressure to our temperature to our hormone secretions. It's important to keep your body synchronized because if it does get out of these rhythms, it can implicate your bodily functions and your regulations.